Assalamualaikum warahmatullahi wabarakatuh to Madam Mazura. For today's video, my groupmates and I are going to present our video presentation regarding our assessment 3 under the topic 2.4 Logical Implication. Here are our group members. Myself, Nurul Batrisha, Nur Shazaliana, Fazriani, and Nurul Irda Nurina. First and foremost, the learning objective we are trying to achieve is to determine whether one statement logically implies another, using a truth table and laws of logic. As for introduction, the statement if P then Q is also written as P implies Q. Hence, P arrow Q is often read as P implies Q to designate the statement which is the implication of Q by P. The following list are ways to express a logical implication. If P then Q, Q if P, P is sufficient for Q, P is a sufficient condition for Q, P only if Q, Q is necessary for P, Q is a necessary condition for P, Q whenever P, Q from P. Next would be the definition of logical implication. The first definition states that it is a relationship between two propositions in which the second is a logical consequence of the first. Hence, if P and Q are two logical expressions and if P implies Q is tautology, we say that P logically implies Q. Here are the symbols for logically implies and not logically implies. Meanwhile, the second definition expresses that it is a false statement only if the first statement is true and the second statement is false. Thus, it is a valid argument whose conclusion is true whenever all the premises are true. In other words, we can say that P1 and P2 and until Pn implies to Q is a tautology.
Hi, so let's move on to the first example. We need to prove the equation in bracket P or not Q implies not P and Q logically implies in bracket not P and Q using laws of logic. To begin with, we use definition of implication to change the implied symbol to or symbol, and next we use De Morgan's law and double complement. For the third step, we use idempotent law and we get not P in bracket not P and Q or in bracket not P and Q. For the last step, we use inverse law and we find T, which stands for tautology. It's proven that the equation in bracket P or not Q implies not P and Q logically implies in bracket not P and Q using laws of logic.
For the next part is example 2. The question is, using a truth table, determine whether not P if and only if Q and P if and only if not Q logically implies not Q implies P. For the first step, we need to write the question, which is not P if and only if Q and P if and only if not Q implies not Q implies P. Then step number 2 is we need to construct a truth table in order to determine the number of rows by using formula 2 to the power of n, where n is the number of the variables. Since we only have two variables P and Q, then we will get 2 to the power of 2 is equal to 4. Therefore, the truth table will consist of 4 rows. To determine the number of columns, we can count the number of the power and plus with n. Then we will get 7 plus 2 is equal to 9. Since we only have two variables, then for the first column P, it is going to be true, true, false, false. While column Q, we need to alternate the truth value and it will get true, false, true, false. The third column is not P, where we need to negate the truth value from column P and it will be false, false, true, true. Then for the next column is to find not P if and only if Q. For biconditional, the statement is true. When both statements have the same truth value, then it will become false, true, true, false. The next column is not Q, where it is a negation from column Q and it will be false, true, false, true. The next column, P if and only if not Q. Since it is also a biconditional, the truth value will be false, true, true, false. For the next one, we want to find truth value of not P if and only if Q and P if and only if not Q. For that, we can assume the fourth column as 1 and fifth column as 2. Since it is a conjunction, the statement is true when both statement is true. Then it will be false, true, true, false. The next column is not Q implies P. It is an implication where the statement is false when the hypothesis is true and the conclusion is false. And the truth value will be true, 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 false. For the last column, we want to find the truth value of not P if and only if Q, and P if and only if not Q implies not Q implies P. We can assume the 7th column as 3 and 8th column as 4. Since it is also an implication, then we will get the truth value is true, 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 true. Therefore, the conclusion is not P if and only if Q and P if and only if not Q is logically implies not Q implies P. Since not P if and only if Q and P if and only if not Q implies not Q implies P is a tautology.
For the third example, construct the truth table for equation double bracket if P then R close bracket and bracket if not Q then P close double bracket logically implies open bracket if not R then Q close bracket. First, we need to change the logically implies symbol to solve this problem. Next, we need to identify how many variables that we have. Since the equation have variable P, Q and R, so we will have 2 to the power of 3 which is equal to 8 column. Next, we put the value of P, Q and R. In row R, we will have TF, 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 TF. In row Q, we will have value of TT, FF, TT, FF. And for the row P, we will have TT, TT, FF, FF. For implication statement, we will get the statement is false when the value of first statement is true and the second statement is false. For the first statement, if P then R, we will get the value of TF, TF, TT, TT and denote it as 1. Then we proceed with if not Q then P statement. But first we need to list down the value of not Q. We will negate the value of Q and we will have FF, TT, FF, TT. As mentioned before, for implication, the statement is false when the first statement is true and the second statement is false. So we will have value of TT, FF, TT, FF and denote it as 2. We will combine both first and the second statement using conjunction. The statement will become true when both statements are true. So we will have value of T, FFF, TT, FF and denote it as 3. Next statement is if not R then Q. We will find the value of not R first by negating the value of R and we will have the value of FT, 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 FT. For the statement if not R then Q, we will have the value of TTT, F, TTT, F and denote it as 4. Lastly, combine statement 3 and 4 by using implication connective and we will have all the row is true. Therefore, we can conclude that double bracket if P then R close bracket and bracket if not Q then P close double bracket logically implies open bracket if not R then Q close bracket, since double bracket if P then R close bracket and bracket if not Q then P close double bracket implies bracket if not R then Q is tautology.
As for the conclusion, a statement is said to be logically implies if it is tautology, but not logically implies if it is not. The truth table and laws of logic can be used to determine whether or not a statement is a tautology. If one of the truth values in the truth table is false, the statement does not logically imply. Hence, we can say that our learning objective is achieved. That is all from us. Thank you for watching.